conference started as a class project, but due thanks to our professor's vision, he turned this project to a public benefit for all. So I'll be calling on our experts to give us and explain what their project is all about. And they will not be only giving us the science about it, but the practical aspects of the project.
First of all, for the short speech you have given. Thank you very much. So what we are going to do now is that we are going to move straight to the presentation. And the presentation is such that it's an eye-opening one in the sense that this is giving the whole world the opportunity to understand what we as wood and biomaterials engineers do and how we can ensure sustainability in building or in developing sustainable building material. And this is something that I appreciate the fact that we are starting it, and I want to urge Professor to ensure that this trend also continues with the next set that will be coming. Yes. So
before we start, I would like to add that this conference is not just about wood, it's about intensive materials and solving waste management problems in Nigeria, so we can also improve our society. So I'll give you the program.
So the theme of this discourse is wood plastic composites, redefining the sustainable materials for the 21st century. Because as you know that we are in the 21st century and the world is tending towards green materials, that is materials that have zero or little environmental adverse effects, and they are materials that are sourced naturally. So wood is one of such materials, and it can be complemented with some other materials to give a very good materials that is capable in terms of the strength, start of the point of or the ways in which it can be applied. So this we are going to look at the first presentation we'll be looking at is enhancing wood product engineering through polymer engineering and adhesive and coatings. Binders, okay, adhesive and binders.
Okay, good morning everyone. My name is Ashimi Tamdore, and I'll be giving a bit of an insight into adhesives and binders in polymer engineering. Now, the world as we know it, previously we were used to using bolts, screws, nails, or I would like to say physical forces to hold down material. Ranging from, if you could remember growing up, if you had a small smartphone, like I remember having my first one at ICO, it was used, when I opened the back, I see a lot of screws and everything, but now, something like this, if you open it, you really see that. So they are more like an invisible force or an invisible strength. You rarely have the opportunity to see them because they're already in action. So now, regarding wood products, or generally speaking, plastic waste, the main focus is for plastics, generally speaking, is to reduce, reuse, recycle, yes. But now, with current trends now, we can achieve all that with much less energy using wood products, using wood materials. For instance, now you can have your sawdust or your wood chips. You get your plastics. You can reduce them any way you want, you can shred them, you can burn them, and you can melt them or anything else. You get a wood plastic composite. Now, speaking of that wood plastic composite, on its own, you can actually have experimented on it myself. You can melt down, let's see, water sachets and put your sawdust, mix together, you get a composite. But then what can we do to ensure it's better? Or what can we do to ensure a longer serving purpose for the material? That's where adhesives and binders come in. Now imagine I want to make a wooden stool like this, something like this now. We design this, like flexible. You can never use a nail to do this. Either it will fracture after a bit of time or it's not going to place into the eye. But with adhesive and binders now, you can have a design like this and nobody will know what it is. Perfectly hidden, but yet still working in a very good condition. Also now, the current trend, I would say the most negative effect of using an adhesive and binder is that it emits, the strong ones emit toxicity. And I feel like cannot imagine it's very toxic to the environment. But now, with the revolution, we're having water-based adhesive, like actual water-based adhesive that have little to no economic power, because little to no impact in the ecosystem. Basically speaking, if I use a water-based adhesive, I can leave it in a room like this. It will remove no smell and to have no negative impact in the ecosystem. For something like enough mandate, if I use it here, even if you are an indoor, a bit of a smell that will give that actually is not conducive for human health. So, and also, I like to call them as smart adhesives, but basically they're mostly elastomer based, meaning if I want to, let's say I want to make a school bench now, something that has a lot of that has a lot of sitting movement, like sit and stand, sit and stand. So basically I can use elastomer based adhesive because it can stretch due to mostly any weight to stretch, and after it will move to go back to the original position. Unlike other forms that if it reaches a limit, there's no additional fracture or ability to have it back. There is no improving longevity of the material. Okay. So now, going deep into adhesive and binders, we are notably there are two types, natural and synthetic. But I'm not really here to talk about natural, since we're looking at the future trends. So basically, natural I'm not saying they're bad, but they has a bit of disadvantage than synthetic, because one, they are easily biodegradable. They can attack the insect fungi seeking to destroy it. But now we have synthetic adhesive, and those fall under thermosetting, thermoplastic, and adhesive for elastomer base. Now, thermosetting adhesives, they are a bit tricky, but they are best suitable for structural applications. That is, thermosetting, that is if you apply the adhesive and it cools, it becomes firm and it holds your structure perfectly well. But for thermoplastic, you can reheat the adhesive and you use it again after. So basically, thermosetting is for permanent situations, and maybe thermoplastic is for temporary. But now, elastomer base, those are perfectly, or I won't say they are perfect, but they're my favorite part. Because basically, they can perform a large range of duties for you, depending on what you want to use for. So basically speaking, the factors I've discussed today, like wood, plastic, biomedical, and the rest of it, I'd like to add that adhesive and binder serve as a very good foundation for your product. Like imagine making a composite, as I said, a sawdust and low floating classic composite. After forming it, probably you use an extruder machine to make your classic composite. Then after it, to bond it, kind of adhesive, and can use a binder. Then after which, you can apply a coating, like if necessary. But then I'd like to say that instead of doing it step by step, you can actually just find a certain material that can serve almost all properties. Like instance, we want to reduce cost and to reduce the load, but you want to overload the material. The overload the material is going to fail, and that is completely against what you are aiming for. But then I would like to say that with polymer engineering, it's not like we're talking about the old type of bond of adhesive, like the shoemakers, adhesive that you see up and down with you plaster on your shoe and the rest. But we're talking about more of improved adhesive. Those that are required for our necessary everyday applications. And I would like to say that thank
you. Thank you very much. You are allowed to carry your book. You are allowed to carry your slide. Don't sleep off. Is it clear? We want 2 or 3 people from this group to come and add one thing that you think you missed out, so that our seminar will be rich. 1 or 2 people out from terminology group. Nobody. They are all asking to come and add color to it. We are waiting for you outside, and we are waiting for you. Thank you. Let's wrap up. Before we come, we just wait for 2 minutes or 1 minute. Re-emphasizing the topic and area you want to put the emphasis.
Okay, so basically, adhesives and binders, they are essential in polymer engineering, where they enable strong bonding materials, reinforcement, and structural integrity, while also improving the performance and durability in various applications. The problems that can be solved through adhesives and binders are structural weakness and joint inefficiency, low dimensional stability and warping, biological degradation, limited design flexibility, material inconsistency, and fire susceptibility. Advantages of polymer-based adhesives and binders are strong bonding strength, durability and resistance, versatility, improved aesthetics and surface finish, lightweight and efficient, and also uniform stress distribution. Disadvantages of polymer-based adhesives are slow curing time, temperature sensitivity, health and environmental concerns, stress from shrinkage and movement, inspection and quality control. Examples and innovation of adhesives and binders are epoxy adhesives, acrylic adhesives, and bio-based adhesives. In conclusion, adhesives and binders are essential in polymer engineering, and they enhance durability, efficiency, and structural integrity. Thank you.
Adhesives are processes that are binding 2 surfaces together in a permanent form. We have different types of adhesives. We have a natural adhesive and synthetic adhesive. Under the synthetic adhesive, we have epoxy adhesive. They are very strong glue made by mixing 2 parts, that's the resin and hardness. They are used for in cars, aircraft, and they are very durable. We have polymer binders. They are very flexible and strong glues. They are used in floors, furniture, and they are resistant to moisture and chemicals. We have acrylic adhesive. They stick very fast and hold well under sunlight and other outdoor conditions. They are used for labels, stickers, car park, and construction. We have the silicone-based adhesive. They are flexible, rubbery glue that handles heat and water very efficiently. They are used in bathroom tiles, ceiling, windows, kitchen. They stay soft and are very flexible. We have the biodegradable binders. They are eco-friendly glues made from natural materials that break down over time. They are used in paper, cardboard, packaging, and environmental products.
Thank you very much. So,
that you all really enjoyed the session we just had now. So, Thank you very much. So, before we move on to the next presenter, so I'd like to ask someone to just, outside of the group member, to just tell us one or two things they learned during the course of the presentation. Because I believe you all learned something. Okay, I'll go first. So I learned that I also have biodegradable adhesives that can be used, and they can be used in paper and packaging because of their biodegradable nature. So it's easy to get degradable, and because of the non-strength application, they find using that word. So that's something I've learned during the course of this presentation. So let's actually go on.
I also like to add something. From the presentation, I got to know that the waste that we see in our rivers here in Ibadan can be utilized in the production of wood plastic by combining it with wood waste from sawmills, then making it into a composite material that can be used in many applications. Thank you.
So we will go on to the next presenter, and this, I want to urge every one of us to brace ourselves for impact, because this one is going to be very, it's energy packed, and so that the energy can resonate around the room. So please, as we welcome Ms. Oluwabukola Victoria to discuss wood plastic composites, we define sustainable materials for the 21st century. Welcome. Thank you. Let's appreciate that, please.
Good morning, ladies and gentlemen. My name is Akimbode Oluwabukola, and I will be speaking on how wood plastic composites are redefining sustainable materials in the 21st century. Now, every year, about 19 to 23 million tons of plastics end up in the aquatic environment and in landfills every year. And Nigeria contributes about 2.5 million metric tons of plastic emissions into the environment annually, with less than 12% being recycled. This means that Nigeria is also the 9th contributor of plastic waste emission into the environment globally, and that's a problem. So, what if the waste in your trash bin today could be the chair that you sit on tomorrow? What if the waste in your trash bin today is the decking you use in your building tomorrow? Now imagine a world that combines the warm feel and the natural feel of wood, and the sustainability, the strength and the durability of plastic. A material that turns plastic waste into beautiful deckings, furniture, and building products while saving our forests at the same time. Now this is not a science fiction. That's what wood plastic composites are. For decades, we've had to choose between the beauty of wood and the durability of plastic. But what if we don't have to choose again? This is why it is important for innovative engineers, producers, and manufacturers to come up with innovative materials like wood plastic composites by attaching economic value to waste. Some of the limitations of traditional wood include hygroscopicity. Hygroscopicity means that it absorbs moisture from its environment and also releases moisture from the environment from time to time. And this also affects the usability of wood as well. Wood is also sustainable to biodegradability. It's vulnerable to fungi, rot, bacteria, and other microorganisms that can cause wood to break down. Other concerns concerning wood include flammability, weathering, splinting, and other high maintenance. Now, engineers and innovators have come up with a hybrid material that combines the strength from wood and the durability of plastic, which is wood plastic composites. Now, it makes wood, this hybrid material is moisture resistant, it is easy to clean, it is easy to maintain, It is recycled, meaning it is saving our world and it is saving our forests. It has consistent appearance and custom finishes, and it's also very flexible in usability and design. Some of the production mechanisms used for producing wood plastic composites includes extrusion and injection molding. Some of the downstream finishes also includes cooling and sizing, surface finishing to improve its appearance, cutting and machining to the suitable shapes that we desire, and coating and painting. The applications of wood plastic composites vary, from indoor to outdoor applications, from your roof to your decking, to your ceilings, to your chairs, your furniture, your tables, and everything you have around you today can be made using wood plastic composites. Wood plastic composites can even be used in creating an entire building. It also finds its applications in interior design. Some of the innovations that we must look at in wood plastic composites technology include smart wood plastic composites. We must look at how to integrate sensors for real-time monitoring and control. We must also look at applications in smart flooring in building systems as well. We must also look at integrating bioplastics, which are biopolymers, which can also be gotten from wood and other biomass, and integrating this in production of wood plastic composites technology. I will conclude with this. While we are thinking of how to build, design, and sustain our world, we must also keep in mind that the future is composites. So think composites today. Thank you.
Please let's appreciate that very well. Just as I saw it, we were able to believe that we really good. So let's appreciate our own. I would like contribution from some of my group members, if they are available. One or two people, I think, should be good.
Who members stand up and go carry your resources.
So you can.
Okay. So, like my team leader said, she has given us the advantages and why plastic composites can be more used in Nigeria, but she never really discussed the possible challenges that we can have converting plastics to wood plastic composites in Nigeria. Now, when we look at the production of wood plastic composites, she talked about extrusion and injection, but we never talked about the initial production cost, because people have the tendency to think that, production of wood plastic composites is very expensive. But when we look at the long-term advantage, we realize that the using wood plastic composites tends to be more cheaper in long term compared to other materials. Also, when we look at comparison of wood plastic composites to other materials that can also be used, when we look at wood, we look at it like, look at the fact that wood is not resistant to termite attack, and during rainy season there is agroscopy. When we look at metals, we see that metals, especially steel, they rust and they are very heavy. When we look at just pure plastic, which is just pure plastic, we look at the work under it and they have lower stiffness and they have an artificial look compared to the plastic composite that have a natural look. Thank you.
I want to add on the benefits of wood plastic composite, which is the utilization of wood waste and recycled plastics. In the sense that we're not actually using the whole wood or the timber harvested from the forest, we're using the waste gotten from the sawmilling industries. And we're using recycled plastic because we don't create brand new plastics for our innovation. And this making it contributes to the circular economy for the plastic, which is reduce, reuse, and recycle. We're reducing the plastic usage and reusing and recycling them. Now, we're talking about reduced deforestation again as part of the benefits. Because since we are not relying on the virgin source itself, we're using the waste, so we're keeping the forest sustainable. And to add to it, we're trying to make it a closed loop. because we are using recycled materials. Now the question is, can the recycled material be recycled again after the end use? And which is yes, it can be recycled again. Thank you.
So you can see it's a wonderful.
Before the next one, I saw some reactions in the city that when somebody tries to criticize or condemn for something you're not supposed to bother, this is a workshop. You just smile and just learn from it. Thank you.
Thank you, sir.
So while we are smiling and learning from the odd that is happening now, so it's also very nice that we also pay our attention, and as much as possible we should encourage those that are speaking, because it's not easy. It's not easy, and you all can do it. Like, it's not easy to come out here and talk. So when they are presenting, you can just give them smiling faces, and also that's going to keep sharing them on. So we are going to go to the next.
Before that,
okay.
I would like to add something. So at our last semester, we learned about some framework of United Nations Framework Convention on Climate Change. From their presentation, I could see that their project, Wood Plastic Composites, could contribute to the goals of the Kyoto Protocol that was developed in Japan in 1997. So kudos to your team. Well done.
So yes. So kudos to the team, and we'll be going on to call onto the podium the next person that will be doing the presentation. So just as I've said, so that I don't as if I'm repeating myself, brace for impact, because the person we are bringing on now is scholar par excellence, and yes. So the topic is something that there was a time when I learned that wood can be used. I was very small. Wood can be used for building. I was like, is it the same wood that we used to burn? And so when there is fire, is the old building not going to burn? So now the person is coming out to tell us what are those things that we can do to use wood as a building material without having to tell that when there is fire, what happens. So join me as we welcome a scholar at the Ajayi Oladamalagide, who will be discussing fire.
Okay. Our protocol will be extended, and I'll be talking on the application of fire retardants and then preservative in enhancing the utilization of wood. And one of the major issues, even from laymen, they know that wood is susceptible to fire break. Wood normally it degrades when they are exposed to different service conditions. They are usually degraded by pests, degraded by fungi, degraded by termites in most cases, and this has actually caused a lot of discrepancies. Some people are actually they are not satisfied with using wood in their construction, using wood in several applications, just because of these issues or problems that wood faces. And we as wood product engineer, it is seen that it's our major field. We've been able to look for means and ways by which all these problems can be mitigated, such that wood can also compete with other other materials that are used in the engineering world. And I'm majorly talking about fire retardant and then preservative. The major function of fire retardant is to reduce the flammability or the combustion rate of wood using several substances, several chemicals that have actually been tested over the years and over time, and also preservatives. And also there are several preservatives that have been tested whereby would extend wood service life whenever it is being used. And the major two forms of fire retardant that I'm talking about is aluminum trihydroxide and aluminum polyphosphate. And the major advantage of these two fire retardants is that they are actually allergen free, because in as much as we want to have an extended service life, we must also consider the harmful effects of all these chemicals on the environment, and some of them could cause respiratory disorders. Some of the halogens are chlorine, and chlorine is actually very toxic. And then we're able to look at how we can use fire retardants that are actually halogen free, especially chlorine, which is toxic. And one of them is aluminum trihydroxide and then aluminum polyphosphate. And the way they work is that aluminum trihydroxide, it exudes moisture, and such that as it exudes moisture on its application, so it extends the ability of wood to actually be resistant to fire attacks. And also we also have aluminum polyphosphate. The way this works is that it forms a char layer on the surface of the wood, such that when wood is exposed to fire attack, this char layer actually helps to mitigate the great impact the fire would have had on the wood. And also we also have several preservatives that are being used. We have oil-borne preservatives, we have water-borne preservatives. The major work of preservatives is to reduce the susceptibility of wood to fungal attack, to termite attacks, and to decays, to molds, and to stains that could actually reduce their service life. And one of them is they are oil-borne preservatives. They are actually preservatives that have oil as their source, and one of them is creosote. Creosote is actually gotten from coal tar. So it is usually used on several applications of wood, such as utility poles. For some people, they have the fear of, oh, can we use wooden poles for our electric connections? And some people choose to use concrete, and all just because they feel like wood can decay, it can susceptible to termite attack. Now, creosotes are now being used to ensure that these woods are actually resistant to fungi and all these termite attacks. And also all these marine applications, for example, the usage of boats. Some people, they've actually sidelined the usage of wood for the production of boats, just because it's covered that when the boat stays on water for long, they're actually exposed to from some marine borers and all these things. And when this creosote is applied on them, it actually mitigates this harmful impact on the wood being used. We also have several other oil-borne preservatives. We have pentachlorophenol, which is actually used to mitigate the harmful impact of termites and fungi on the wood when it's in service. In service. Also, we have other water-borne preservatives. We have chromated copper arsenate. This is actually used majorly for all these fungi and termites, also to reduce the impact of this fungi and termites and other decaying organisms on the wood. Also, we have not just all these water-borne preservatives that are made of chemicals. We have other bio-based preservatives that are now in use. For example, we have chitosan. Chitosan is actually made from chitins, and chitins are actually they are gotten from the endoskeleton of all these shrimps, all these crabs, and because it actually possesses a positive charge, and this positive charge actually reacts with the microbial cell membrane with the negative charge of microbial cell membranes of all these microbes, and this reduces their function whenever they are in contact with wood. So, and also we also have other plant preservatives, such as the linseed oil. We have several oils that are actually used in this as an application in wood to reduce the harmful effect of fungi and termites. And there are, if you ask me that why exactly are we doing all this, is it to make wood compete with other materials? Well, if you say so, definitely, because if all these things are done, we can ensure a longer service life and an extended durability of wood whenever it is in use. And also sustainability. So some people complain of, okay, if I buy a metal chair and I buy a wooden chair, and it is liable for me to replace that wooden chair in like 5 years, but then that metal chair can last for like 10 years. So they will keep on producing and then getting new chairs, getting new wooden chairs. So this can actually be mitigated, and then also leads to sustainability. It leads to sustainability by which it reduces the excessive usage of wood by extending its service life whenever it is used. So these are ways by which wood have been worked upon to ensure that it serves the customers well, it serves the engineering world well. And we believe so much that there are several other.
Yes. Okay. Yes. So we are going to continue from where we stopped. And this topic is, I also have a story to narrate as regards this. So I remember I did a project in 300 level like this, where I made, together with my team members, we made a diamond-based tool. But there is something that did not make the tool really stand out. Though the tool was presented at the 75th anniversary, so it was really well covered, but it was met with one challenge, and that's the finishing. So we have a team of people that are going to make a presentation on how we can enhance wood products with the use of coatings and finish. So hopefully I gained something that I'm going to use to upgrade that project in this workshop today. So we will be calling on our scholar, Akinpade Oluwapelumi Ademola.
Good morning, everyone. So, my presentation is on polymer coating on wood products. It enhances and sustains wood products. So, I go by the name of Akinpade Oluwapelumi, standing on the executive protocol. The outline of my presentation goes thus: introduction, the types of polymer coating that we have, the benefits of polymer coating that are there, application and innovations, challenges and future of polymer coating, and then conclusion. So our introduction, what are polymer coatings? So if you ask me what are polymer coatings are thin layer of synthetic natural polymer that are used to cover the surface of wood products to make them have an aesthetic appeal. So why do we apply polymer coatings to our wood products? These coatings serve as functional primary, providing protection against environmental degradation and enhancing aesthetic value. Like I have said, these polymer coatings, when used on our wood products, they enhance the aesthetic value and also improve the mechanical properties of the wood. So we have different types of polymer coating. We have the natural polymer coating and we have the synthetic polymer coating. The natural polymer coatings are coatings that are naturally coating, like from our animals and plants. But the synthetic are man-made that are made chemically or from different animal and plant ones, but they are like chemicals are added to them, so they are not more naturally coated. So the next one. So the types of natural polymer that we have the wax, we have the silax and many more. Then for synthetic, we have the polyurethane, we have the epoxy resin, we have the alkyds. All these natural and the natural ones, they are like the wax helps to protect the surface of the polymer from moisture. So it gives the wood that we apply it on to be it helps the wood to be moisture resistant. While the wax gives it a glossy look, so that whenever moisture is, let's say water is poured on the wood now, it will not allow the water to enter into our wood to affect it or allow the wood to have molds and make it susceptible to insect or fungi attacks. So these are the things that the natural polymers coatings does to the wood. Then the synthetic ones, like the polyurethane now, it gives the wood a glossy look that makes it well shiny, like it gives it the glossy look like that is always shiny, like this one that we have here now. I'm very sure that the polymer coating that they did to this was like that of polyurethane and all. So the acrylics provides UV stability. Acrylics, like when acrylics is applied to you, the main function is to make sure that the wood is very susceptible to UV light, that ultraviolet light. Then we have the epoxy resin. Epoxy resin is a chemical and moisture resistance common in industry and high performance uses. So when epoxy resin is applied on the wood, it is basically used industrially, mostly used industrially. So it also gives the glossy and the aesthetic appeal to our wood. So moving on, so how polymer coatings extend wood lifespan. So if you have been asked that how does the polymer coatings that we are talking about extend the lifespan of wood, it prevents moisture absorption. So firstly, when you apply polymer coatings to wood, the first thing it does to the wood is that it seals up the pores of the wood to not allow moisture from entering the wood and degrading the wood. The next one is protecting the wood against decay. When moisture is not allowed to enter the wood, obviously protecting it against decay, like decay fungi, insects, and all that. So it shields the surface from UV radiation. When the polymer coating is applied on the wood, it shields it from UV radiation. So when UV radiation reflects directly on our wood, it affects the wood chemistry. So when it is coated with polymer coatings, that will not happen. Then it improves mechanical stability. It enhances the visual appeal. That's aesthetics. When wood is applied, when polymer coatings are applied on our wood, it gives it a very good appeal. That's aesthetics appeal. So the next one is reduce maintenance requirements. In this our wood now, like this one for example, the maintenance for this is just to clean from dust. But when normal wood is applied, we might need to be fixing it again because due to weathering and some other environmental factors that might happen to the wood. But this one now is just to clean the dust from the wood when it is applied. Then application and innovation, the way we apply our polymer coatings to wood. It might be brushing, it might be spraying, it might be dipping, it might be coating. So these are the brushing. Obviously, the chemical is being used to brush the surface of the polymer coating. And dipping, the whole wood that wants to cover with polymer is dipped into a solution of polymer. So when it is dipped into the solution, it takes the surface of the wood takes the polymer, and then when it seals the pores, then we have our good finish. So innovation, self-healing coatings which fixes minor scratch. Like this too now. This type of I'm sorry I'm using this as an example because this is the only polymer coating I can see around. So when this has a minor scratch now, when it is clean, you might not be able to see the scratch again. But in wood, when there is a scratch, it has affected the wood cells, it will be there, and the scratch will be visible in that one. So future challenges, high cost of advanced coating. Some coatings are very expensive, like mostly the synthetic ones. They are expensive, and to procure them, some basic wood industry might not be able to buy polymer coating, but in advanced countries and advanced industries, they are able to get that. So that's not an issue to those ones. Adhesion issue, the issue of the polymer coating to like stay on the wood is also another one. But in the recent research now, they already know that okay, this polymer coating is very suitable for this type of wood. Some woods with tiny pores and the ones with wide pores. So we know the type of polymer coating to use for those ones and not to use for them. So my conclusion, polymer engineering transforms wood with advanced coating boosting durability, beauty, and eco-friendliness. So this innovation shield wood from damage and smart features, creating low maintenance, sustainable products. Let's keep pushing for greater coatings and recycling to make wood a sustainable innovation. Thank you.
I learned a lot of things. Initially, I thought we use coatings just to enhance the aesthetic appeal, but while the lecture was going on, I learned that we can also use it to enhance the durability, to protect it against UV radiation. That's a whole lot. I've learned a lot of things in this class. Let's appreciate now, moving to the next thing is to take contribution from the group members that are available. Thank you. So, yeah.
Thank you so much. Standing on the existing protocol,
just as our lead speaker has spoken, and then he has majorly covered the whole aspect. So I'll just also be buttressing what he has said. So, and briefly, polymer coating, as he has said, is used to like protect wood. It's like a thin, continuous film layer that has like spread all across the wood surface to like enhance the wood ability and properties, and also to protect the wood from UV rays and then other insects or fungi attack. And also, as they are not only about protection, it is also about performance, because the continuous flexible film that are formed that is like laid on the surface of the wood, which use the wood for moisture and then prevent it from the UV light and everything, helps in expanding the service life of the wood. So it's about the performance per se, not only about just protection. So once it is like laid on it enhances the performance of the wood. And also by this particular aspect of ours also ticks some of the UN SDG goals. I think SDG 9 concerning the innovation by producing advanced polymer coatings will help in the innovation, and also SDG 13, which is about the climate action, because once the service life of wood is improved through polymer coating, then there won't be frequent need to keep cutting trees in this. So there will be frequent use of trees since the service life is being elongated. So it's not like, okay, we use this thing and then we have to get another one. But since the service life is being elongated, so there will be like delayed cutting of trees in wood, which can also help with the climate action. Thank you.
Thank you very much. I appreciate it. Yeah.
Good morning, everyone. So I'll be giving more insight on the innovations in this polymer. So for the innovations, we have the self-healing coatings. So I learned that these self-healing coatings, the release of microcrystals that helps to extend the service life when they are scratched. And an example of these nanoparticles, we have titanium dioxide and we have silica. Silica is the one inside this white paper like this that we all know. I don't know if it's familiar with everybody. So it helps with water repellency, the scratch, then ideal for outdoor furniture and decks. Then for the bio-based polymers, so from renewable stocks like soy, lignin, they help to reduce fossil fuel use, lower carbon footprints. Then talking about the challenges that is faced in real life situations. If you're having a project now, a low budget project, you're going to experience high costs. So that's for that advanced nano coating or smart films now. We're going to because they're more expensive, they're 2 or 3 times more expensive than the one we used to use in the real life scenarios. So we're going to be experiencing higher cost, and for this our project that we're just starting up, we're going to be a low budget. That's one of the challenges we face. Another challenge we face is the volatile organic compounds emission while using this thing. Example, volatile, that solvent-based coatings that don't release these volatile organic compounds, and they cause environmental hazard as well in the process. But during research, we're still working to curb these challenges and improve on our research.
Good morning, everyone. So I would like to add to what they have been saying, and I will just talk about 2 benefits of coatings on wood. First, I will talk about the increase in the economic value of the wood product. So because of these coatings, there has been an added value on the wood product and has increased the value of the wood product, because it, as I've said, the wood coating enhances the durability and the aesthetic and the mechanical properties of it, because it it makes wood more stable, as it were. And another benefit of it is that wood coatings create act as a sealant and prevent the leakages. Is it leakage, or what's the name of the wood preservative from the wood, because most of this wood preservative, what's the English? They see part of the wood from time. So the wood coating serves as a sealant to seal the surface to prevent the chemicals from seeping out. And I would also talk about one of the, just to buttress the limitations of wood coating, which is the compatibility of the wood coating to the wood surface. So because of the hydrophilic nature of the wood and the hydrophobic nature of the coatings, they tend to, the molecules not tend to bind very well. Some of them, especially when the wood is not well dried, so it affects it oftentimes. So, and it is also important that it is a limitation to the kind how we use wood coating. And another thing is So another thing is use of some of the wood coatings, especially the synthetic ones, also contain chemicals which are poisonous to the environment. So it is also best that we look at innovations and alternative of sustainable of bio-based coatings. Thank you.
Yeah, thank you. Good morning, everyone. So just to make an extra comment on the epoxies. So basically, you would actually not really find epoxy being used regularly for coating of wood, primarily because it's unlike other coatings that just affect the look on the surface. Epoxy actually affects the texture, but epoxy is actually a very good innovation when it comes to high performance environment. Typically, historically rather, when you want to use wood in marine environments like your boats, you have to use chemicals like creosote, and these things are very toxic to the environment and toxic to marine life. But because of the dimensional stability that epoxy adds to wood, as well as the moisture resistance, you see that when epoxy coated wood is being used in marine environment, the service life of such wood is extended without that damage that is associated with the use of harmful chemicals, as well as even in industrial settings, like maybe where you are using wooden walls for thermal variating environment, like a kiln, maybe the walls of a kiln, you might not typically want to use wood due to the fact that there is relatively higher humidity than the normal environment, and the fact that the temperature inside such places are usually high. So the epoxy introduces that layer of moisture resistance and thermal stability to the wood, allowing it to be used in places where you would otherwise not find wood suitable. Thank you.
That's a wonderful delivery from the group members, so it's really nice. Let's appreciate them also. Now, real quick, okay, before that, so I forgot to call on the members from the group that presented before for their contribution. So if you are still willing to chip in your contribution, we would like to have you.
So, what is our project capacity so that we can carry the day one? Let's do the last one, then we'll now
Okay. So, without wasting any much time, so we are going to be listening to the presentation from the last team. So, that's on enhancing wood products and wood lamination with the use of biopolymer and eco-resin. And to make the presentation is our team lead, a leader par excellence, in the person of Emmanuel Okmara.
All right. I want to start by asking questions. The first is, how can we be environmentally responsible? The second one is, as engineer, how can we contribute to a future that is environmentally friendly? And the third one is, amidst our world filled with toxicity today, can we really make our constructions or our productions without the use of harmful substances? And how can we manage a free environment? Today, I am going to talk about how we can enhance wood products through polymer engineering and with the aid of biopolymers and eco-resins. What are biopolymers? There are two words, bio and polymers. Polymers are large structural units which are composed of repeating structures called monomers, and these are bonded covalently. And what is bio? Bio is just the short form of biological. Now, bringing the two together, biopolymers are polymers that are derived naturally. Going to eco-resins. Eco-resins are resins which are made to further improve friendliness to the environment. Now, how can we enhance wood products with the use of biopolymers and eco-resins? As we all know, most of our constructions, most of our products that are made from wood products are actually used with petrochemical substances which are toxic to the environment. Nigeria is one of the major exports in crude oil, and as such, most of our products can be narrowed down to the input of petrochemical substances. However, amidst all these factors, we can still impute our own alliance as engineers to make sure that these factors do not affect the future of construction, the future of wood products. Biopolymers can be narrowed down to sources such like cellulose, lignin, chitin, and some other natural occurring plants. Yes, we have modified plants too. That's why I use the word natural occurring plant. Then, let us go to what biopolymers are used for. Biopolymers can be used for different products, such as the textile production. We can also use it as packaging materials, which is largely a product that is constituted in the environment by petrochemical substances, such like plastics, nylon. All these are also polymers, but they are not biopolymers. But because of the fact that Nigeria produces majorly petrochemical substances from crude oil. Now, how do we use biopolymers in wood products? As we all know, let us put it whenever we are making products such as floor tiles, wooden floors, and all. If you look around us today, there has been an emergence and large usage of ceramic tiles, and just as we can see in our environment now. But that can be replaced with the use of biopolymers. And biopolymers serve as adhesive and also coatings as well. And these are used in the new emerging trend in wood floor and wood tiles. Compared to the ones that we have been using before, the wood floors and the old tiles that are made from wood, we can see that there are a lot of large effluents of volatile organic compounds, VOC, and that can be tracked with the leachability of substances like phenol formaldehyde and urea formaldehyde. In some countries, those products have been banned, but here we still use them, and in other countries they are still largely used, and this constitutes nuisance in our environment such that it affects our health, and this causes eye problem, nose problem, even urinary problem. And that is why sometimes when you sleep on the bare floor, you notice some kind of irritating actions, whether with your skin or with your health. And in fact, there are some situations where this kind of health issues has been traced down to the usage of all these adhesive and binders that are used in the production of these products. However, we can still mitigate these factors with the use of biopolymers in making adhesive, with the use of biopolymers in making packaging materials, with the use of biopolymers in making most of our products that has to do with wood and even in other factories or other field. Let us go to eco-resins. Eco-resins, just as we know, are resins that are made from renewed materials which produce less volatile organic compounds as compared to the normal petrochemical synthetic resins that are being used. And this largely helps our environment further. These are used in wood tiles, are used in eco-laminated floors, and such that in all laminations we have a bond strong and a greener environment. Eco-resins and biopolymer are used in our world today, in fact, in leading world, to reduce the effluent of volatile organic compounds. And as engineers, we should all work towards building a sustainable environment, not just sustainable, a greener environment. Eco-resins and biopolymers should be integrated in most of our use, especially when it comes to adhesive, to reduce the impact of health issues, to reduce its impact in health issues. And in most cases, we have patients that are carcinogenic due to the fact that these substances are being used in our world today. Eco-resins and biopolymers are used majorly in eco-laminated floor. And just like I said earlier, eco-laminated floor are compared and are better when they are compared with our normal floors today. If you look at our normal tiles that we use today, in temperate environment, you feel that the floor feels colder, and as such, temperature cannot be regulated. But with the use of eco-laminated floor, even in temperate region, it does not really affect the touch whenever you touch it. Also, the weight of ceramics being used for floor tiles is so huge compared to that of the eco-laminated floor. Should we also talk about the slipperiness of the wood tiles, and as such can cause accidents in homes? How about the health risk that it also affects whenever you stay so close to it, inhaling such chemicals and adhesive that will be injurious to the health? Eco-laminated floor is one of the escape from the toxicity that we experience in our world of today. Biopolymers, eco-laminated floor. A way forward in our industry of today, a way forward that will help us to build a sustainable environment and a greener environment. Therefore, we as wood product engineers are encouraged to dwell the paths of using biopolymers in our products, in our adhesive, and also in all that we do, and also to produce products that would not constitute waste and constitute more problem in our environment. So eco-resins also, apart from the fact that it contributes to a greener environment, it also helps us to actually mitigate waste products. And how do I mean? If you go to wood factories today, you see that a lot of waste are being generated. The use of this waste are only narrowed down to combustion, using it as fuel for cooking, using it also in other areas that do not constitute or do not promote environmental friendliness. The usage of these waste products in eco-laminated floor or eco-resins helps us to bind these products together in having a product that helps in greener environments. Off-cuts are being used and are bonded together with eco-resins to make products like floor tiles, to make products like a wonderful table and some other products like that. There are other things that we can keep talking about with the use of eco-resins and biopolymers. But I believe that with the use and with the adoption of biopolymers and eco-resins, we can have and contribute to a greener and sustainable environment. Thank you.
So that was a very wonderful delivery. It was the last, but it was not the least. Thank you very much for having us. So with this, we are going to take contribution from some of the members of the group that are seated here today. So please, let's have you.
Good morning, everyone. I just want to add a few points to what my colleague, my team leader, has just said. So I have a case study whereby in 2024, an eco-resin flooring company retrofitted a school and in Denmark. So after retrofitting the school with the use of eco-laminated floorings, the maintenance team reported that there was no report of delamination of the panels after a year, and also they measured the air quality in the school, and they measured that it was 60%. There was 60% better air quality levels than when they were using the former flooring, which the former flooring they utilized. And also, I also want to add that the future eco-laminated flooring has some economical advantages in the cost, and it costs higher than standard flooring, but then in the long run, it extends the lifespan to at least 5 or 10 years than the normal one. So in the long run, you are paying once for something that you won't have to maintain or take care of after for a long while, because it's now being manufactured better with use of eco-resins. Now, the future trends that we looked at in the eco-laminated flooring systems are self-healing coatings. This is a situation whereby the flooring has bio-based microcapsules in the top coat that when it scratches, they can release a resin that will automatically repair the surface that has been damaged or scratched. And another future trend is smart flooring, which integrates the use of sensors in order to detect foot traffic, monitor the wear of the floor, and also to control the heating from the floor. You can also use some hybrid resins to replace the eco-resins used in flooring. For instance, adding soybean and glycoxyl acid to the resin. Thank you very much.
So, as a good member of the board, so I would just like to add that under UNFCCC, which is United Nations Framework Convention on Climate Change, forest community, if you have a forest community, you can earn carbon credit on it. Why? Because you are also preserving carbon stock and also improving sustainability. So through epoxy and biopolymers, we are also enhancing sustainability and preserving the carbon stock in the forest. So we are also creating a pathway for us to start earning funds or carbon credits from UNFCCC. So thank you.
So I believe with this we've come to the end of this workshop, and we would like to appreciate every one of us for listening. We also appreciate the presence of our lecturers, Professor T. making sure that everything is going on very well and is well coordinated. I'd also like to have an input from our professor to help us cap everything. Thank you very much, sir, for
I'm very happy about our presentation today, and I know today will not be the end. Why? Anywhere you go, it's an opportunity to exploit. I will encourage all of us to dig deep down and learn more about the use of wood and the application of polymer engineering. Most times, when they're asking you what do you study or what are your future options, because you are not versatile in the depth of knowledge, you think that you are lacking some areas. But by this exposure, you know that you can work absolutely in every area, and you know that you can enhance the quality of your environment. And we are talking about sustainability. It's very important to know that anytime we consume waste from our environment, we are really enhance the quality of that environment. Once again, I say thank you to all. We have done very well.